So when it comes to probability, the hardest part about probability is knowing what strategy to apply. Back in the previous problem, the previous warm-up that we did, we used slot diagrams, okay? We had 3 light bulbs, we had a probability of defective, we found the probability of not defective, and we used those probabilities. All the probabilities were equally likely. The probability that the light bulb was defective was 0.03 or 3%. And so it was the same for every light bulb. When that happens, you can use these slot diagrams. Sometimes slot diagrams aren't the strategy we're going to use. So I'm going to introduce a new strategy, and it's called a Venn diagram. Okay? And the key word in a problem that you can use a Venn diagram is when you have the word both. Okay? So if you have the word both, that's usually a clue or a red flag that we're going to use a Venn diagram to solve the problem. Sometimes what goes inside the Venn diagrams are probabilities, and sometimes they're numbers. So I want you to read this problem to yourself and decide what the Venn diagram looks like. How many circles are there, and how are the circles going to be arranged? Are they overlapping? Are they separate? Are we talking about mutually exclusive events here, where the 2 events are totally separate, or is there an and situation? So read the problem to yourself and let me know what you think. How are the circles arranged? They're not going to be separate. They're definitely going to overlap, and the key word for that is the word both, right? There are some things that are shared by both. How many circles do I have total? Just 2 in this case. So let's draw a Venn diagram. Smartboard's about 5 seconds behind me. We're going to draw the circles, and then we're going to have them overlap. And we're going to label each of the circles. What are my 2 kinds of things that we have here? Chocolate and vanilla. So we're just going to label them as such. Chocolate and vanilla. Now, it is important that I put a rectangle around the 2 circles because there is an area outside of the 2 circles. And what does this area outside the 2 circles represent? The none, okay? What if I'm a chocolate chip cookie dough person, okay? I don't like either of just plain vanilla or plain chocolate. Or I'm a mint chocolate chip person. So I would be on the outside, and that happens as well. So where do we start in a Venn diagram? And you did this back in geometry, so you should know a little bit about it if you remember geometry. Where do I start? In the both, on the inside. So what number goes there? 18. Now these are all counts. And again, like I said, sometimes probabilities are given and you use the probabilities, and we'll look at one of those in a minute. But for now, we're talking about counts. These are 18 people out of 50 that liked both. Now we're going to kind of work backwards, and I see 36 like vanilla. This is not okay. Don't write this. 36 like vanilla and 24 like chocolate. What is wrong with this picture? Ashlyn? It's too many. If I add them all together, don't I have more than 50? It tells me I only asked 50 people. So what we have to be careful of is that doesn't say 24 students only liked chocolate, right? It doesn't say that. It says a total of 24, so I already have 18 of those accounted for. So what do I need to do? What goes for chocolate only? Subtract 18 from 24, and what do you get? 6. So we're going to have 6 out here. And then how many people only liked vanilla? 18. Do I have any people that liked neither of these or none? How do I tell? Add them all up and subtract it from 50, because I should have a total of 50. So when I add these up and I subtract from 50, what is my none category? I'm sorry? 8. Good. So I'm going to go ahead and write 8 on the outside. Use a different color just so it stands out. An 8, and that represents the none, neither chocolate or vanilla. Slow smartboard. All right, so now we're going to answer some questions. Okay? How many, and we're going to use the Venn diagram to do that. How many of these people like chocolate? Or, I'm sorry, is that how many? Notice the word says find the probability that. So all of these numbers should be divided by what? 50. A probability means we're either going to write it as a fraction or a decimal. And the decimal, if we're doing it, should be between 0 and 1. So look for those key words. It's not how many, but what's the probability that? What's the probability that a student likes chocolate? Now, if it said like chocolate only, that's a different answer, isn't it? Okay? The word only is not there. So we're talking about all chocolate lovers. So therefore, we would have 24 out of 50. You can reduce that fraction or you can write it as a decimal. Either is okay. And I got point what? 0.4 what? 0.48. How about doesn't like vanilla? What am I going to add up? So the 6 and the 8 were outside of the vanilla circle. Okay? So 6 plus 8 would be 14 divided by 50. Good. And again, you can reduce that fraction, or you can just divide them and give it to me as a decimal, and you should get 0.28. Oh, good grief. Again, smartboard issues here. I swear I wrote it. It's just coming slowly. All right. I'm going to try it again. 0.28. All right, there we go. Likes chocolate or vanilla. If I'm looking at the or, normally we would do this using the or formula. And I can show you how to do that the other way as well. But using the formula. But with the Venn diagram, if I have it already made, what am I adding together? The 6, the 18, and the 18. The chocolate or vanilla means everything on the inside of the circles in terms of the picture. Okay? So 6 plus 18 divided by 50, and I should get 42 out of 50. Okay. I would like to look at that a little differently using the formulas. What if we didn't have a Venn diagram? Come on, baby. Good grief. 42 out of 50, which is 0.84. Smartboard is garbage. Okay, so let's just kind of take a step back for a second. Remember that if we like chocolate or vanilla, chocolate, what's the symbol for or again? U, good job. Chocolate or vanilla, okay? Let's go ahead and write this formula in context. You remember how we did that? What is it? It's the probability of chocolate plus the probability of, plus the probability of vanilla. And then what do I have to do? Subtract, because I don't want to count twice, the middle part. Remember that? So it's the probability of, I'm going to subtract off the and. What's the symbol for and? The upside down U. And let's just see if I get the same thing. What was the count for chocolate? The whole, if I look not at the Venn diagram this time, but just look at the numbers that are given to me at the very beginning, the probability of the number for chocolate was 24. Do you agree? So I'm going to say 24 out of 50 plus 36 out of 50. So 24 out of 50 plus 36 out of 50, liked vanilla. And then what was the overlap, the and? The both was 18 out of 50. Go ahead and add those up. Again, they all have common denominators, so I can just combine them. 24 plus 36 minus 18 is what? Gee, is that a shocker? Didn't we expect it to be 42 out of 50? So the formula is what we've done before and what we did before Thanksgiving still works. It's just that the strategy of the Venn diagram makes it a little bit quicker, okay? And just makes it, and the reason that it works is because this subtraction that we do here, didn't we already subtract to get these two numbers? So that's why it kind of works. We've already done the subtraction. Okay? All right, let's try D. What do you think about D? Likes neither chocolate nor vanilla. Look at it from a Venn diagram perspective. Neither chocolate nor vanilla. What number am I looking at? The 8. So it's going to be 8, and since we're looking for a probability, it is 8 divided by 50. And again, you can reduce that fraction. I'm going to have to stop recording, I think, because the smartboard's not keeping up. So 8 divided by 50, which happens to be 0.16. Or you can reduce that fraction as well. All right, how about likes chocolate and vanilla? Where am I looking at in the Venn diagram for that? Where they overlap, which happens to be in the middle there, which is going to be 18 out of 50. And this gets me y'all have calculators, 0.36. 0.36, thank you. Okay, I'm going to stop recording because this is ridiculous. All right, very good. So what I'm going to have you guys do is try another one, okay? This one's going to be, I want you to try on your own. And this time I'm giving it in terms of probabilities, not counts. So the numbers are going to go, oh. All right, y'all. This smartboard is just acting crazy. What was it, 0.16? 0.36, okay, sorry. All right, so let's try one more on your own, and I'm actually going to stop recording after this one because it's being cray-cray. All right, so here's one on your own. I want you to draw the Venn diagram, remember where to start from, work yourself backwards, and then answer some questions. I lied. Given that is another problem, so I don't want you to do this one. I want you to do this one instead, okay? Sorry, this is the one I want you to do. Hopefully when you drew this Venn diagram, these questions got answered very, very quickly because it's nothing more than just looking at the Venn diagram and answering the questions at this point. Sometimes Venn diagrams are very, very helpful, and this is one of those cases. If I'm going to draw the Venn diagram, the word both clues me in that I'm going to have the circles overlap. If I can ever get the rectangle drawn for the, there we go. All right, so I'm going to have two circles that overlap. One of those circles is going to represent a breathalyzer, whereas the other circle is going to represent a blood test. So I'm going to call them breath, BR, and blood, BL. And again, where do I start in a Venn diagram? In the middle. So I'm going to put 0.22 right in the middle because that represents 22%. And then I am going to have to work backwards because it does say 78% of drivers are given a breath test, but we've already accounted for 22% of those, so I'm going to have to subtract them. How many people were, or what percentage of people were only given a breathalyzer? 0.56, good. How many people, or what percentage of people were only given a blood test? 0.14. And then what do I also need to account for? The none, okay? And so what percentage would be that? We're not given a test at all. 0.08. Good. Okay, we got to make sure when you complete a Venn diagram, because you're going to have a quiz next Monday. And on that quiz, part of it's going to be to complete a Venn diagram. I'm looking for all of those to be filled in. Don't forget the none, okay? It's required too. All right, so looking at this Venn diagram, we can answer these questions very quickly. What's the probability they were given just a test? Any of them? What do I add up? Everything on the inside? So 0.56 plus 0.22 plus 0.14, or I can just subtract and give me the complement of the none. Either way works. What do you get? 0.92. Maybe. It'd be fun to watch this as a recording. I wonder if it's as slow on the recording as it is for us in class. It's kind of crazy. All right, how about number 2? What numbers am I looking at here? A blood test or a breath test, but not both. So what am I looking at in the Venn diagram here? Davis? Perfect. I'm going to add 0.56 and 0.14. And when I do that, I get something maybe. Of course I was going to do that. I think it's Smartboard's forcing me to slow down, which is not a bad thing. But really, okay. 0.56 plus 0.14. And those two probabilities together is 0.7, correct? Okay, or 70%. How about neither test? What number am I looking at here? The 0.08. Don't even have to do a whole lot. It's already part of the Venn diagram, and we're done. Okay? So Venn diagrams are very helpful as a tool to be able to answer questions when you have two events where both can happen. One and the other can happen. Okay? So I'm going to stop the recording at this point and try to move on with something different.